Hello, welcome to my channel. Today we will be learning 5 different functions that are must for everyone who will be learning OpenCV. So let's get started. So first of all, we will do is we will import our library. So our library is import CV2. And first function we are going to learn is our grayscale image. So we will take a regular image and convert it into grayscale image. So first of all we can write image is equal to sorry image is equal to cv2 dot imread and in which we can define our path. So first of all we can do is we can define our path first. And so for that purpose we can first save our file save as functions dot py. So we can save our file and now we can assign a path. So what we will do is we can write path is equal to resources backslash book dot jpg. So now we can write here just path and here is our folder where we have OpenCV folder. Here is our py file, here is our resources, and here is the name of book.jpg. So we can move to our code. And then we want to show our image. So we can write cv2.imshow and we will define it as book comma and we will say the wanted display is our image. So we can write img. So we will add the wait key. So our wait key is cv2 dot wait key into 0, which means infinite. So now what we can do is we can simply print it. So we can run the function and here is our output, the book image. So what if we want to convert a image into a grayscale? So if we are using imread function, we can simply write 0 in front of path and it will convert it into a grayscale image. So here we can simply insert 0 and we can print it. So here is our grayscale image. Our grayscale image is successfully changed. But what if we are using a webcam, and what if we don't want to use the path function? We can later to convert image into gray by writing. So we can write the image gray is equal to cv2 dot cvt color into image cv2 dot color underscore. So there are different colors, but in OpenCV we are using BGR to gray, BGR to gray. So if we doubt 0, we can remove it. And now we want to add another function. We can copy it and paste it. So we can simply copy it from here and paste it. And we also change the function from here to grayscale, and now run the code. Sorry, my bad. We can remove color into small. C is capital, but other is small. So we can run the code, and here is our results. So first is our original image, and the second is our gray image. So we can successfully convert the image. So the next function we are going to use is adding blur. There are many different ways to adding blur, but the most simplest one is using Gaussian method. We will declare image as image blur, image blur is equal to cv2 dot Gaussian blur. So so it can take the parenthesis in term of image gray. So we can set the dimension, and we can also need sigma value. So after that we can simply copy copy it and paste it. And now we can also change the name of image gray to image blur, and also change the from image gray. Sorry, image blur. So now we can run the code. So from here we can get the output. So here is our blurred image, here is our grayscale image, and here is our simple image. So now we can successfully change into blur image, and from here we can also increase the blurriness to increase the value here. We can put it 9. So we can run the code, and here is our output. The image is more blur than previous. So our next and third step is to we will move to edge detector. That is very important and is the basic of a lot of different projects that involve in OpenCV and Python. So the first thing, we will declare our image as image can. Image can is equal to cv2.canny and we use the parentheses for image blur, and we can add the threshold parameters with the value of 100 by 100. So next we can copy it and paste it and change the values to image can. And also change from here to can. So now we can print it. Sorry, my bad. We can change can, and now we can print it. So here is our blur image, and here is the image detection, edge detections. We can also change the values of detection. So we can change the value from 100 to 100, 100 to, we can change it into 100 by 200. So here you can change the difference. So in according to your project, you can change the values as you need it. So later on we can have the can image with these edges. So now we can increase and decrease size. In technical language we can say it dilation. So we can write image dilation is equal to CV2 dot dilate CV2 dot dilate and we can give the image. We can use here image scanning, and we are going to use a kernel now. Now, what is a kernel? A kernel is basically a matrix that we use to go through, iterate through an image itself actually perform a function. So in order to declare a matrix, we are going to import our numpy library. So first we can import our numpy library as np import as np. So now we can import our numpy library and we are going to declare our kernel. Now we can declare our kernel is equal to n kernel is equal to np dot once np dot once. So this is kernel that will have rates of 1. So this is kernel that will have values of 1. So how big we can and you can also type what is type of data in this kernel. So what big matrix we want is we want 5 by 5 matrix. So we can write it 5 by 5 5 5 np dot int 8. We can use uint. If you don't understand, we can print it. What is the kernel and what are the values? So we can print kernel. So we can print the result, and from here we can get the result of 5 by 5 matrix which we give in the list. So now we can move to our next step. So we can add a kernel here, kernel, okay, and after that we can set the iterations. We can iterate one time. After that we can print it, we can copy it and paste it here. We can change it to image dilation. We can also change the name of image canny to image dilation. So now we can print it. Run the code, and here is our 5x5 matrix, and here is our can image, and here is our image dilation. So we can see that it is more sharpened than image canny. So now we can also change the value. To change the value, we can change the iteration from 1 to 3 and run the code. So from here we can see the difference of previous and the 3 iteration. So if we want more iteration, we can change. So this way you can have the more and less effect of functions. So we can change it easily. So the last thing is we are going to learn is to do reverse dilation, which is called erosion. So we can add image eroded is equal to cv2.erode. We can use parentheses and we can get here the image of image dilation, because image canny and image erode is as little bit same, so we can use image dilation, image dilation, and we can get the same kernel which we use in dilation, and we can set the iterations is equal to, we can set it as 1, and after that we can simply copy paste and paste it in here, and we can set it eroded, and we can also set here eroded. Now we can run the code, and here we can get the kernel, we can get the 5x5 matrix of ones, and in result we can see that here is our dilation image, and here we can get the eroded image, which is uh, different from this. So now we can increase the value for better results. We can iterate it as 3, and now print it. So we can close it first, and after that we can run the code, and here we can get the eroded image, and here is our dilation image, and here is our can image. So it is so these functions are very useful in a lot of different projects. It can be very useful to have it in your pipeline to actually pre-process image, to track image, or you are also used to detect functions, detect locations of image, and we can have a lot of functions getting out of these functions. So that's it for today. So one thing to note here is that we have almost 1, 2, 3, 4, 5, 6. We have 6 windows. That is messy. When you want to see the results of your project, it is not looking good. So later on we are going to learn how to put all the images together in one screen in one window, without writing a lot of code. So stay tuned for that. I will see you in the next video.